Welcome to this video on addressing in computer networks, part of the Data Communication course. I'm Asadullah, and I will be guiding you through the essential concepts of network addressing. The concept of addressing is fundamental. It is the method of assigning unique identifiers to every node in a network. Think of it as a digital postal system, ensuring data is delivered precisely to the intended recipient. There are three primary types of network addresses: physical, logical, and port. Physical addresses, like MAC addresses, are hardware-based. Logical addresses, such as IP addresses, are software-based for internet routing. Port addresses identify specific applications on a device. The physical address, or MAC address, is a hardware-based unique identifier assigned to the network interface card, or NIC. It is globally unique, ensuring no two devices share the same MAC address worldwide. Key features of the MAC address include its permanence. It's burned into the network card during manufacturing. It has a local focus within a LAN and maintains a static nature, functioning exclusively at the data link layer, or layer 2, of the OSI model. MAC addresses are 48 bits, or 6 bytes in total. They are written in hexadecimal format, typically separated by colons or hyphens, as shown in the example. 001, A, 2, B, 3, C, 4, D, 5E. A MAC address is divided into two 24-bit parts. The first 24 bits form the OUI, or organizationally unique identifier, assigned to the manufacturer. The last 24 bits are the NIC ID, a device-specific identifier also assigned by the manufacturer. MAC addresses enable Layer 2 delivery, using the data link layer to deliver frames to the correct physical device within a local segment. Switches use MAC address tables for efficient LAN traffic management. For broadcast communication, the MAC address FFFFFFFFFFF is used. This universal address allows a single sender to reach every device in the local network simultaneously. The logical address, or IP address, is software-based and assigned by network protocols. It is used for global routing across the internet and is hierarchical, helping routers find paths to distant networks. When comparing IPv4 and IPv6, IPv4 is the legacy standard with 32 bits, offering about 4.3 billion unique addresses. IPv6 is the modern standard with 128 bits, designed for the virtually infinite growth of the Internet of Things. IPv4 uses 32 total bits and is formatted in dotted decimal notation. It consists of 4 octets, or 8 bits each, separated by dots, as seen in the example 192.168.1.1. IPv6 boasts high scalability with 128 total bits. It uses hexadecimal notation, structured into 8 groups of 16 bits separated by colons, as illustrated by the address on the screen. An IP address has two dual parts: the network part, which identifies the specific network for routing, and the host part, which identifies the specific device within that network for final delivery. The packet routing process involves 3 steps. Step 1 is tagging, where the sender adds source and destination IP. Step 2 is routing, where routers find the best path. Step 3 is delivery, where data reaches the target host. Dynamic and global connectivity is a hallmark of modern networks. The global reach enables communication between any two connected devices, and IP addresses are typically assigned by internet service providers. Dynamic IP and DHCP rely on the DHCP protocol, or Dynamic Host Configuration Protocol, to manage assignments. These IP addresses are temporary, assigned for a specific period known as the lease time, and are cost-effective as they allow ISPs to reuse addresses for inactive users. The DHCP assignment process, known as DORA, includes 4 steps: discover, where the client broadcasts to find a server; offer, where the server offers an IP address; request, where the client requests the offered IP; and ACK, where the server confirms the assignment. Port addressing, working at layer 4, the transport layer, with TCP/UDP, identifies specific applications like HTTP, mail, or gaming, acting as a service ID. The endpoint is defined as the IP plus the port, creating a unique socket connection. Port numbers are 16 bits long, defining a full range from 0 to 65,535. This represents the total available service endpoints per IP address for different applications and services. The multiplexing process differentiates addresses at 2 levels. The device level uses the IP address to identify the physical hardware, while the app level uses the port address to identify the specific service running on that hardware. This is called multiplexing and demultiplexing. Port numbers are organized into 3 categories: well-known ports, 0 to 1023 for common services, registered ports, 1024 to 49151 for defined applications, and dynamic private ports, 49152 to 65535 for temporary connections. Standard port assignments include HTTP on port 80 for regular web traffic, HTTPS on port 443 for secure web traffic, FTP on port 21 for file transfer, and SMTP on port 25 for email sending. To simplify network use for people, human-readable names are used, such as URLs and email addresses. These text-based addresses are mapped to IP addresses using the Domain Name System, or DNS. In summary, the MAC address is for local frame delivery. The IP address is for global packet routing across networks. The port number is for service and application identification. Thank you for watching this video. The image sources used throughout this video are listed here.